The extinction of the dinosaurs, one of the most significant events in Earth's history, marks the end of the Cretaceous period and the Mesozoic era. Approximately 66 million years ago, the dinosaurs, which had dominated the planet for over 160 million years, vanished in a mass extinction event. This event, known as the Cretaceous-Paleogene extinction, wiped out about 75% of all species on Earth, including not just dinosaurs but also many marine reptiles, ammonites, and certain plants and animals. While there is no single explanation for the event, a combination of catastrophic occurrences played a role in the extinction. The most widely accepted theory for the extinction of the dinosaurs is the impact hypothesis, first proposed in 1980 by Luis and Walter Alvarez. This theory posits that a massive asteroid or comet struck Earth, causing catastrophic environmental changes that led to the extinction. The evidence for this impact includes a layer of iridium, a rare element on Earth's surface but abundant in asteroids, found in sedimentary layers around the world that date to the time of the extinction. This layer, known as the KPG boundary, marks the transition between the Cretaceous and Paleogene periods. The discovery of the Chicxulub crater on the Yucatan Peninsula in Mexico provided further confirmation of the impact hypothesis. This crater, measuring about 150 kilometers, 93 miles, in diameter, was formed by a bolide estimated to be 10 to 15 kilometers, 6 to 9 miles, wide. The force of the impact was equivalent to billions of atomic bombs, and it released a tremendous amount of energy. The immediate effects of the impact would have been devastating. The asteroid hit with such force that it vaporized rock and sent molten debris into the atmosphere, some of which re-entered the atmosphere and caused intense heat, igniting global wildfires. The impact would have generated massive tsunamis, particularly in the shallow seas that covered parts of the Yucatan at the time. Evidence of these tsunamis has been found in sediment layers in various parts of the world. The impact would also have triggered massive earthquakes, releasing pent-up tectonic energy and causing widespread geological upheaval. However, the most significant effects of the impact were long-term. The debris thrown into the atmosphere would have blocked sunlight, creating a nuclear winter effect. This dramatic reduction in sunlight would have caused global temperatures to plummet, disrupting ecosystems and halting photosynthesis in plants. Without sunlight, plants and phytoplankton, the base of the marine food chain, would have died off, leading to a collapse of food chains. Herbivorous dinosaurs, which depended on plants for food, would have quickly starved, followed by the carnivorous dinosaurs that preyed on them. Marine ecosystems would have similarly collapsed due to the disruption of photosynthetic organisms. In addition to the cooling effect, the impact would have released large amounts of sulfur into the atmosphere, particularly from the vaporization of sulfur-rich rocks in the Chicxulub region. This sulfur would have formed sulfuric acid aerosols, further blocking sunlight and causing acid rain. Acid rain would have devastated plant life and disrupted freshwater and marine environments, making survival even more difficult for many species. Furthermore, the impact would have released carbon dioxide from the vaporization of carbonate rocks, contributing to a long-term greenhouse effect. After the initial cooling, the planet would have experienced a period of global warming as the carbon dioxide accumulated in the atmosphere. While the impact hypothesis is the most widely accepted explanation for the extinction, other factors likely played a role. During the late Cretaceous period, Earth was already experiencing significant environmental changes. One of the most important was the Deccan Traps volcanic activity in what is now India. The Deccan Traps are a large volcanic province that erupted over a period of hundreds of thousands of years, spewing vast amounts of lava and gases into the atmosphere. These eruptions released large quantities of sulfur dioxide and carbon dioxide, which would have contributed to both short-term cooling and long-term warming, similar to the effects of the Chicxulub impact. The combination of volcanic activity and the impact may have amplified the environmental stresses on Earth's ecosystems, making survival even more difficult for many species. The Deccan Traps eruptions would have had profound effects on the environment, even without the asteroid impact. The sulfur dioxide released by the eruptions would have formed aerosols in the atmosphere, reducing sunlight and cooling the planet. This cooling would have affected global climate patterns, leading to changes in precipitation and the disruption of ecosystems. At the same time, the release of carbon dioxide would have contributed to global warming in the long term. The combination of these climatic changes may have created a seesaw effect, with periods of cooling followed by warming, making it difficult for species to adapt. Additionally, the eruptions would have released toxic gases such as hydrogen sulfide, which could have poisoned ecosystems. Another factor that may have contributed to the extinction is sea level change. During the late Cretaceous, sea levels were relatively high, creating shallow inland seas that covered large parts of the continents. However, by the time of the extinction, sea levels were beginning to drop, exposing land that had previously been underwater and altering coastlines. This change in sea level would have affected marine and coastal ecosystems, leading to habitat loss for many species. The reduction in shallow seas would have particularly impacted marine reptiles and other organisms that lived in these environments. The combination of these factors, asteroid impact, volcanic activity, and sea level change, created a perfect storm of environmental stresses that made survival difficult for many species. While some animals managed to survive, the majority of life forms, including all non-avian dinosaurs, perished. The only dinosaurs that survived were those that had evolved into birds, which are the modern descendants of theropod dinosaurs. The extinction of the non-avian dinosaurs left a vacuum in ecosystems around the world, allowing mammals to rise to dominance. Before the extinction, mammals had been small, nocturnal creatures that lived in the shadow of the dinosaurs. With the dinosaurs gone, mammals diversified and evolved to fill the ecological niches left vacant, eventually giving rise to the large mammals that would dominate the Cenozoic era, including humans. The KPG extinction event had long-lasting effects on Earth's ecosystems. The recovery of biodiversity took millions of years, and the planet was left with a very different set of species. While some groups, such as mammals and birds, thrived after the extinction, other groups never fully recovered. For example, marine reptiles and ammonites, which had been abundant in the Cretaceous, were almost entirely wiped out. In the plant world, flowering plants, angiosperms, became dominant after the extinction, largely replacing the conifers and cycads that had been prevalent during the age of dinosaurs. This shift in plant life further shaped the evolution of animal species, as new types of plant eaters evolved to take advantage of the changing flora. In the years following the discovery of the Chicxulub crater and the development of the impact hypothesis, scientists have continued to gather evidence to refine our understanding of the extinction event. Some researchers have proposed that the extinction was not caused by a single event, but by a combination of multiple factors that occurred over a relatively short period of time. This press pulse theory suggests that long-term environmental stress from volcanic activity and sea level changes pressed ecosystems to the brink, while the asteroid impact provided the final pulse that pushed them into collapse. Recent studies have also examined how different groups of dinosaurs were affected by the extinction. While all non-avian dinosaurs went extinct, some groups were already in decline before the asteroid impact. For example, large herbivorous dinosaurs, such as the hadrosaurs and ceratopsians, may have been struggling due to changes in plant life and climate during the late Cretaceous. On the other hand, theropods, the group that includes birds, were more adaptable and may have been better able to survive in the changing environment. In addition to studying the causes of the extinction, scientists have also looked at how life recovered after the event. Fossil evidence shows that the first few million years after the extinction were a time of rapid evolutionary change. Mammals, in particular, underwent an explosion of diversification, evolving into many of the major groups that exist today. Birds also diversified, filling many of the ecological roles that had been occupied by flying dinosaurs such as pterosaurs. This period of rapid evolution is known as the Paleocene-Eocene recovery, and it laid the groundwork for the ecosystems that exist in the modern world. In conclusion, the extinction of the dinosaurs was a complex event that resulted from a combination of catastrophic factors, including an asteroid impact, volcanic activity, and sea level change. The evidence for the Chicxulub impact is compelling, but other environmental stresses likely contributed to the extinction as well. The aftermath of the extinction saw the rise of mammals and birds, which would go on to dominate the Earth in the following epochs. While the extinction was a tragedy for the species that perished, it paved the way for the evolution of new forms of life, including humans. The extinction of the dinosaurs was one of the most dramatic events in Earth's history, shaping the planet's future and paving the way for the rise of mammals, and eventually, us. From asteroid impacts to volcanic eruptions, multiple factors combined to bring about their end. If you enjoyed learning about this fascinating chapter of history, make sure to subscribe to the channel for more in-depth explorations of the past and beyond. Thanks for watching, and I'll see you in the next video.